All right, inductive reasoning. This is your introduction to the logic unit. All right, so we're going to jump right on into it. Inductive reasoning is reasoning that reaches conclusions based on a pattern of prior examples. So we're going to be looking at a lot of patterns. A conjecture is a conclusion. Okay, so that's pretty much what you need to remember. Conjecture is a conclusion, they're the same thing. All right. And it can be true or false. So the conclusion does not necessarily have to be true. All right, an example. Use inductive reasoning to make a conjecture about the following situation. So the first one says, Ashley is tall and she is good at basketball. So a conjecture that you could make is that she will make the basketball team. Okay, so again, she may or may not make the basketball team, but that's a conjecture that we can make. All right, the second example says, use inductive reasoning to make a conjecture about what number will come next in the sequence. So if I look here from 1 to 3, from 3 to 9, and from 9 to 12, I can see that each time it's multiplying by 3. So then we just got to figure out what is 27 times 3, which is 81. Okay, so that's an example. Example C, the numbers represented below are called triangular numbers, and we got to figure out the next one. So I'm just going to draw a picture. So if you notice, this one has 1 dot, this one has 2 rows, and then the bottom row has 2 dots, and da-da-da-da-da. So you can see. So each row is adding 1 dot. So now we're going to have the bottom row of 6 dots, and then we just build the triangle from there. Okay, and then if you count them all up, should be 21. All right, moving on. Oh, and then another thing that is important to note, if you just look at the numbers, to get from 1 to 3, that's plus 2. To get from 3 to 6, that's plus 3. To get from 6 to 10, that's plus 4. To get from 10 to 15, that's plus 5. To get from 15 to 21, that's plus 6. So that's another way you could also look at it. So a conjecture may not always be true, again, and it only takes one false example to show that it's not true. We call that a counterexample. So those are really important. All right, give a counterexample to prove this conjecture false. So this one says angle 1 and angle 2 are complementary angles. All right, and we know that complementary angles are angles that part equals 90 degrees. So, and then another thing is that, yeah, we're good. All right, so then the conjecture says angle 1 and angle 2 form a right angle. We need to disprove that. We need to prove that that's false. So right here, we see that this example, I have angle 1 and angle 2. Now, angle 1 is 60 degrees. Angle 2 is 30 degrees. So they're complementary because they add up to 90. However, they do not form a right angle because the example that I drew right here is non-adjacent. Okay, so yeah. All right, here we go. More examples. Draw a picture and make a conjecture. So I went ahead and made a graph right here. I'm going to go ahead and graph these points. So we have A at -1, -1. We have B at 2, 2. That's A, that's B. And then we have C at 1, 2, 3, 4. 4, somewhere around there. Okay. So what is a conjecture that we can make? Well, we can make the conjecture, sorry, it's not perfect, but we can make the conjecture that these 3 lines are collinear. So we could say that A, B, and C are collinear. Another conjecture you could say is that the line that joins A, B, and C has a slope of 1, something like that. So conjectures aren't necessarily one right answer. Draw a picture and make a conjecture of this. So we have angle 1 and angle 2 form a right angle. So let me start by drawing a right angle and splitting it into 2 different angles. So that's my right angle, and I split it into angle 1 and angle 2. So now we're going to make a conjecture. Based on this information, we could make the conjecture that angle 1 and angle 2 are complementary. Okay, another conjecture that we can make is that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So yeah, like I said, there's not necessarily one right answer. It just depends on what the question's asking you. Number 3, draw a picture and make a conjecture again. So we have points A, B, C are collinear, and D is between B and C. So I'm going to draw 3 collinear points. Okay, so we have A, B, C, and then it says that D is between B and C. Okay, so what conclusion can we draw? We can draw the conclusion or make the conjecture that A, B, C, and D are collinear. That is one conjecture that we can make. That's not the only conjecture, but that is one conjecture that we can make. Number 4, draw a picture, make a conjecture. So again, ABC is a right angle, so I went ahead and drew that already. And let's see what conjecture we can make. We could say that the measure of angle ABC equals 90 degrees, right? Because the right angle is 90 degrees. So that's one conjecture we can make. That's not the only one, that's just one. Number 5, we have P, Q, R, and S are non-collinear. And then we have these important bits of information. PQ, QR, RS, and SP are all congruent. So I'm just going to draw PQ. Okay, so PQ, and then QR. Okay, so those are congruent. RS. Okay, and then it says SP. Wait a second, P is way over here. Well, what do I need to do to make this make sense? Let me try that again. So I need to make sure that when I'm done, S can connect back to P. So I'm going to have to make this a closed figure. All right, so we have Q, R, S, P, and they are all congruent. So what conjecture can we make? We could say that P, Q, R, S is a square. Okay, that's one conjecture we can make, or we could say that it's a rhombus, because both squares and rhombus, or rhombuses? I don't know the plural, sorry. They both have 4 congruent sides. All right, so those are 2 different conclusions we can make. I gave you 2, you just needed 1 though. Number 6, give a counterexample and prove the conjecture false. Angle ABC and CBD form a linear pair. So the conjecture is that ABC and CBD are congruent. So this is ABC right there. This is CBD right there. Are they congruent the way that I drew them? No. So because of that, we could say, okay, what if the measure of angle ABC was, I don't know, 120 degrees? Then the measure of CBD would have to be 60 degrees, and those two are clearly not equal. So they are not equal. So there's your counterexample. It's not fancy, there's not a specific way to do it. You just need to explain it the best way you can. So you could just say that the measure of ABC is not equal to the measure of angle CBD in this case. Give a counterexample, prove the conjecture false. All right, so segment AB, segment BC, and segment AC are congruent. And then we have that A, B, and C are collinear. All right, well, let's try it out. So let's say this is AB. Put the A on top. So A, B, BC. Okay. And then it says AC. So again, we have that same problem. So let's try this instead. And that way, they can connect. And they can also be congruent. And we've just proven that A, B, and C are not collinear. So A, B, and C are not collinear because they form an equilateral triangle. Okay, equilateral just means they have equal sides. Number 8, give a counterexample again. So for this one, it says that A, B, plus BC equals AC. So basically, if we add this plus this, it equals the whole thing, which is the segment addition postulate, so we know that's true. All right, the conjecture says that AB equals BC. So AB equals BC. Well, that doesn't necessarily have to be true. So let's take a look. All right, so let me doctor this up a little bit. Okay, so let's say that I put B here, and I say that, I'll just make up a number, 6, and then that's like 4. All right, so we would say, okay, well, AB is 6, BC is 4, AC is 10. However, AB, which is 6, does not equal BC, which is 4. So we have just proven that this is false by basically saying that AB does not equal BC. Number 9, give a counterexample, prove the conjecture false. So this time we have the information that 1 and 2 are adjacent angles, and I already drew an example of adjacent angles right there. Don't forget, adjacent angles are angles that are touching. They are right next to each other, no space in between. The only thing between them is a line. So this one says that 1 and 2 form a linear pair. Well, look at the example that I drew. A linear pair looks like this. Well, not like that. Hold on. So first of all, it's a line like that. This is clearly not what I drew. But the example that I gave you is a linear pair. So angle 1 and angle 2 do not form a linear pair. But they are congruent. Adjacent, sorry. Okay, so yeah, we just proved it wrong by a drawing. Number 10, same thing. Counterexample to prove it false. Points A, B, and C are collinear. So I'm just going to draw that real quick. All right, so I just made 3 collinear points. The conjecture says that AB plus BC equals AC. Well, that's always true, isn't it? Because that's the segment addition postulate. However, I could say that that's not true if I do this. Okay, so the given part is still true. A, B, and C, well, I did that out of order. A, B, and C are still collinear. So I didn't mess that up. But the conjecture now says, okay, AB, which is the whole thing, equals BC equals AC, okay? So let me just make up some numbers. Let's say that this is 5, this is 7, and that means the whole thing is going to be 12. So it says AB plus BC equals AC. All right, so let's see. AB is 12, BC is 7, and AC is 5. Is that equal? 12 plus 7 is 19. Does that equal 5? No. So we just proved that that is not always true. All we had to do was change the points around, but they're still collinear, so we didn't break the rule. The rule just told us that they had to be collinear. All right, guys, so that's your introduction to logic, and yeah, guess I'll see you later.